Get loopy today, that's right. Yeah. I thought my jokes were bad. Okay. Loops. And I really don't like running through slides like this, just showing slide after slide. And I always want me to do this. But anyway, so I'll show you the examples, and then I'll show you a slide, an example in slides, try to make it less painful. But we've done loops already, but this chapter formally treats them. So a lot of the stuff, we won't cover stuff we already know. Try to get into the good stuff and call it a day. So go back here. Okay, so in this chapter we've got, you're learning about the advantages of looping, loop control variables, nested loops, common mistakes, and then a for loop, and then some common applications. That's basically what they're doing. So you've already seen the value of loops. You've seen things where you ask the question, if they don't get it right, you ask it again, stuff like that. So there's a lot of different purposes for them. The basic idea is you operate on a set of data over and over and over until something causes the loop to exit or end. This is the loop's structure, and I beat this into you many times already, but you know that the line has to come up right above the diamond, and if it doesn't, you need to take whatever's above it and slide it down into the yes side of the diamond. Does that make sense? Get some caffeine, and we'll start to help. This is just sugar, so anyway, the loop structure. And so the thing that tells the loop how it's doing, how it's progressing, is called the loop control variable. And so like if you're counting from 1 to 10 and the loop is going to do something 10 times, so you call your loop control variable I. It needs to be initialized and then tested every single time through. So you initialize it to 1, you do your thing, you test it, is it 10? No, and you repeat. And we did the thing about how the programmer died. He read the shampoo bottle, the rinse, rather, repeat. We did that, yeah. So that's half my material right there, and I've already done it, so I haven't created the other half yet. The body of the loop must alter the loop control variable, or you have an infinite loop, which is not good. So how are loops controlled? You either have a counter, where you say, okay, do this 10 times. It's called a counter-controlled loop. Or you have a condition-controlled loop, where if the user keeps hitting Y, you continue, and if not, you bail out. So in the book, they call the loop that executes a finite number of times a definite loop. It's predetermined, right? So if you wanted to do something 10 times, you'd make a definite loop. And I think they have an example of this here. And this incredibly useful program prints hello out to the screen 5 times. So this is exciting. Let's take a look at it. Let's see. Pretty basic. I'll just write this thing up. There's 2 ways you can write this, actually. The easy way to do it is to use what we call a for loop. And to do a for loop, make this big enough so you can see it. What you do is you create a variable. This is the loop control variable I, and you say for I equals, and then you put your starting value and your ending value. So it's going to go from 1 to 10. It's going to do something 10 times. The next statement, it goes at the end, and then anything you put in the middle there is the loop code. So if I wanted to print this is fun 10 times, we'll do it. So amazing stuff. Okay, now you can have some fun with this. You can step it by 2's, so it'll go 1, 3, 5, 7, 9. Actually, the way I've got it written. So you can actually adjust it in increments other than just 1 if you want to. So like in that case, it would run 4 times 1, 3, 5, 7, 9. No, so it's incrementing by 2. So when it gets to 11, right, it's going to go 1, 3, 5, 7, 9, 11. Now 11 is greater than 10, so it'll fall out of the loop. If you take the step 2 off, it's implied that it's a step 1. You never have to actually adjust the I. It does it for you. Right? But if you're going to do a while loop, then you do have to adjust it. So here's how it would look using the while loop. So you can see here, you initialize I to 1, so I'll just abbreviate this. LCV stands for loop control variable, and you have your do, and then you do what you have to do, and then you increment, so you're adjusting the loop control variable here, and then you're looping as long as I is less than or equal to 10. So that'll get the job done. At least it should, unless I did it wrong. Well, I've got it doing 20 times because the first one does 10. Well, I know what I'll do. This is more fun. So it's 10 in the first, 10 in the second. But I mean, looking at this, you're writing more code to do it this way. It doesn't look as nice as this. So if you're going to do a loop a fixed number of times, the for loop's really the way to go. Just about every language has that, and it's a lot cleaner than the while loop, really. So, by the way, this while loop is a post-test loop because the test is coming at the end. So when it says do, it will go into the loop at least once. Nothing's stopping you from going into the loop. The question is, when you reach the end, do you go back for more? This condition, well, it's this right here. This condition has to be met to go back for another pass. Now, if I had put the condition at the beginning, now you got a pre-test loop. So you can't even get into the loop unless you meet the test up front. And when you reach the bottom, it'll always come back and ask again. So really the only difference is that a pre-test loop may never work, may never get in, but a post-test loop will always fire at least once. So usually we use post-test loops for you do something once for a user and then you ask them, do you want to do it again? Right, so you know you got to do it at least one time. So you put your test at the end, and then so that would be something like this. But normally that type of loop is a sentinel-based, or a condition-controlled loop. This is a counter-controlled loop, and so a condition-controlled loop would say, you know, you want more, and so you call this variable x. And x, see, I'm going to have to get rid of some of this code here. We don't even need I at all at this point. X as string loop while x not equal to, let's say, n. As long as x is not equal to n, it'll keep on going. And of course, n will bail out. Pretty cool stuff. Okay, so sentinel controlled loop. And it's the sentinel is the n really. It's the thing that says you're out. And then, X is the loop control variable, and it just repeats until the user realizes how silly it really is, and they say N. Of course, it does help if you tell them what their choices are. So if they type no, it won't like it. And until they say N, right, then they're out. So different ways of doing things, and they all have uses. It just depends on what you're trying to accomplish. So that's that. Indefinite loops are loops that don't perform a specific number of times. That's different from an infinite loop. An infinite loop never stops. An indefinite loop, you don't really know how many times it'll go. It just depends on usually on the user. And we just looked at one of those. You must alter the loop control variable in an indefinite loop, right? If I don't ask the user if they want more, I'm not altering X at all, so now I've got an infinite loop. That's why it's really important that you alter the X every time through. That just doesn't look fun at all. Let's move on. Let's see. 3 steps should occur in every properly functioning loop. You provide a starting value for the variable. Now, I didn't do that here in this example. That doesn't always, you can't always get away with that. Actually, when you dim excess string, it initializes the string to empty. So you are really initializing it. You just don't know it, or it's done for you. So X is initialized to an empty string. So it's going to go through the loop once, and it won't be N. Of course, you're asking them here, so they're going to type something. But you've seen other variations of this, like, for example, if I wrote the loop like this: do while X equals Y. Now in this case, the only way you're going to continue is if X equals Y. Well, great. The problem is I created X here and I never set it to anything. So when it asks is X equal to Y, well, it won't be. It'll be an empty string. So here's a case where it would never enter the loop, and I'd go to run it and it would just sit and laugh at me. Well, that's because the loop control variable has to be initialized, and so I'd have to say X equals Y. Then I would get into the loop, and then what they do from there is up to them. Right, so again, it depends on how you write your loop structure as to whether or not you have to initialize it or not. So when they say 3 steps that should occur in every properly functioning loop, provide a starting value for the variable that will control the loop. Well, okay, sure. But sometimes you don't really have to. But as a general rule, you should always be thinking, okay, what is that loop control variable right here, this X? What does he need to be initialized to get into the loop? And now, of course, if I put the test at the end, this, do I need to initialize X? Well, I'm going into that loop no matter what, because it's post-test. The question is, what will they say when I ask them if they want to keep going? See, in this case, I don't have to initialize X. There's no need to, because it's going to go into the loop no matter what. And I'm going to ask them inside. So when the book says, you must always provide a starting value, nah, not really, but most of the time probably. It just depends. It's a good Clinton answer. It depends what is means. What is. Test the loop control variable to determine whether the loop body executes. Obviously you have to do that. That is critical. A loop has to have a test. If you don't test it, it's not really a loop. So that's a critical thing. And altering the loop control variable, again, if you don't do that, you've got an infinite loop. So that's important too. Well, there are nested loops, and we haven't done too much with nested loops yet, but just to show you one, this. For let's do it this way. For years equals 1 to 10. For months equals 1 to 12. Print year, month, next. I have no idea what this is going to do. Let's see what kind of smoke comes out of the computer when I run it. Yeah, not much. Oh, and of course I did this on purpose. I should have said year and month, right? But you notice when I do that, these are in bold. That's usually a bad sign. Those are reserved words in the basic language, and I didn't even declare them either. So when I say dim year as integer, and year doesn't turn normal font, see if I say years, it does. So watch for that. Some variables you really can't use because they're reserved. It might let you use them, but you're playing with fire if you do. So, oh, I love this keyboard. I really do. It keeps giving me W's. Okay, years and months, and then this should be years, months. So what I get then is year 1 up through 12, and then on it goes through that. So you might be doing some type of a table, like maybe you're printing up financial data or something, and you need to go across 10 years, and there's 12 months per year, so you have a nested loop inside of a loop. And that's what you got here. You can always tell, and when you see a next and a next underneath it, it really helps a lot to indent your code so you can spot this kind of thing. When you see that, whenever I write a loop, I always indent my code out 5 characters out with a tab. And notice I did it again for the body of that loop. So it just sort of helps you to see where things are at. It's very good practice to do that. So nested loop. And that doesn't look fun either, so we'll move on. Avoiding common loop mistakes. Okay, neglecting to initialize the loop control variable. We sort of did that a few minutes ago. Neglecting to alter the loop control variable. We did that too, and you saw the infinite loop. Using the wrong comparison with the loop control variable. That is one that will get you into trouble. It won't work so well in for loops. Let's go to something a little different. For do while years are let's see what I'm going to do here. Greater than or equal to 0 and years are less than 12. Print years and this. Okay. Don't need months. What I'm after here is I want to print years from 1 to 12. When I run it, it goes from 0 to 11. So like I'm off by 1, and why is that happening? Well, first of all, what will years be coming into the loop? I created this variable up here. What is years going to be initialized to? 0. So now you're famous. You're on film footage. Years will be 0. Well, Okay, so we really want it to be 1. So problem, you failed to initialize the loop control variable. So let's do that. So we set it to 1. Now if I run it, it goes 1 to 11, but it still doesn't go to 12. So that is because I'm not properly testing my condition. This shouldn't be years less than 12. It should be less than or equal to 12. Or another way I could do this, I could say less than 13, because 12 is less than 13. Either way would work. And this part of the test over here really would be better to say greater than 0. It's not really necessary to do this, however, because it always increments by 1. So why bother to test if it's greater than 0? It has to be. It is, even to get into the loop. So that code is redundant. It's not really necessary. I could just write it like this. Do while years less than 13. And now it goes from 1 to 12. So 2 things. You have to initialize the loop control variable properly, and you have to test it right. So say less than or equal to 13. It'll include 13. So that's another thing you have to watch for. It's things to look out for. Including statements inside the loop that belong outside the loop. This one is more of a performance thing. Sometimes what people will do is they'll have to do a calculation. So they'll say sales, let's see, amount as single equals 23, tax rate as single equals 6%, and then cost as single, and then they'll say cost equals amount times 1 minus tax rate. Right, I'm thinking straight, so it'll take, it's after taxes, right? It'll be 94% of its original value. I shouldn't call it cost. It's, let's do this. Take home, okay, gross and net. How about that? Net is what you take home, right? Gross, is that right?
Yep.
Net, tax rate, and let's make this 100. So if you make $100, 6% tax rate should be 94 net. So okay, so cool, you got a calculation. And you may want to print that at some point. And what people sometimes will do is they'll put this into the body of the loop. Like this. Well, the deal here is that you're doing this calculation 10 times or 12 times, and what's the point? Because it's the same value every time. There's no need to do that. It doesn't really belong there, you know. And so sometimes people will put code inside of a loop, and the program works. It's just doing the same thing over and over that doesn't need to be duplicated. So obviously the programs, I run it still works fine, but you're doing one extra step inside of the loop. Well, that can add up, especially if that loop runs a lot. If you're going 100, 200, 1,000 times through a loop, you've just added 33% overhead to your loop. Well, approximately. Depends on what you're doing, but it's not needed. So that's another thing to watch for. Only put code in the loop that needs to be there. That's really more, like I say, more of a performance issue to think about. So what they do is they walk in the book, they walk through all these different scenarios, and they give you examples to demonstrate all this stuff, which we basically just did that. So rather than regurgitate all this stuff. As exciting as that would be, you can look at it. Here's neglecting to alter the variable, loop control variable, and wrong comparison, and it's putting stuff inside the loop that shouldn't be. See, like, you look at this one, you've got inside of a while loop, they're doing a calculation that never changes. Same thing I just did, basically. But they're using their own little cryptic pseudocode for that. That doesn't look fun, so let's move on. So then it talks about using the for loop, and we've talked about this already as well. It does everything in one nice, concise statement, which is what it really makes these things nice. So for loops, they give an example here. Talk about that. Then they conclude off with some common loop applications. And so one of the kinds of applications is using a loop to accumulate totals. And so, for example, you might want to average up a series of quiz scores, let's say. So just as a simple example, you might have a total and you want an average. Average being a single because it might be decimal. Enter a score. Score as integer. And then total equals total plus score. And then I need counter. Here equals counter plus 1. Loop until score is less than 0, let's say. So they're going to enter scores until they enter a negative number. And that means they're finished. The average will then be total divided by the counter. Sort of. Let's see if that's really true. If I... Oops, that doesn't look very nice. Fix this too. Okay, so I'm entering, let's see, if I go 50 and 100, the average should be 75, right? Uh-oh. I didn't print it out. And I did that on purpose, of course, to show you what happens if you don't do that. Okay, average is 7. Okay, what was I doing? 50 and 100. Average is 40. That doesn't look right. So there's a bug in my code. Well, let's look at the logic. What is counter going to be when I hit the initial do statement here? Right? Remember?
0, so you can have 3 scores.
Yeah, it's going to be 0. That's right. And so counter will be 0. They enter the they enter the score. Counter becomes 1. 0 because counter equals itself plus 1. They do the loop. They enter another number, counter becomes 2. Then they go in the loop again, they enter a negative 1. It's added to the score, and the counter is incremented to 3. So your get me out of here value is being counted. It's being counted in the loop. So how will we deal with that? Well, there's a couple ways we can handle this. We say if score is greater than or equal to 0, then do these things. So with it done like this, if you enter a positive number, we're cool. The score is greater than or equal to 0, does the code, and we loop back up. If they enter a -1, that is not greater than or equal to 0, so it will skip these 2 lines of code, get to this point, bail out of the loop. So I think this will work. Let's see. If I go 50, 100, and now I'm getting a 75. So you have to watch for stuff like that. You know, in these loops, they can be kind of tricky that way. That's where Visual Basic is nice, right? Because you can step through your code and see that, whereas here you're sort of like flying blind a little bit. But the reason I know how to look for it is because I've done so much programming that A, my hair fell out, and B, because I've done so much, I know what to look for. So, is that worth it to you? I don't know. But anyway, so that's something there, and then this, but it's an accumulator. It's accumulating a total, and then it's dividing it to get an average at the end. So that's one purpose of a loop, is as an accumulator type of application. So they give you, they start talking about real estate prices and this various types of things to get you all excited about it. Then they go through this example here, which doesn't look fun, so let's move on. The next one is using a loop to validate data. And you've done this already, right? You've seen this before. If I what is your age, and how do I do this here? So you're going to go into a loop, you're going to ask what their age is, and you're going to keep looping until their age is greater than 0. Right? So if they run this and they say their age is 0 or negative something, it keeps asking them until they get it right. So if I put my age in, whoops, sorry, then it's cool, it's happy. So you're saying, yeah, right, put your real age in, moron. Okay, so there we go. So, it's validation, just loop validation, which we've already been doing. So that's another purpose for loops. And then lame example, and then we got our third thing, limiting what they're saying here is, look, if you keep bugging them for their age, they might get upset. We can't have that. So maybe we should limit them. If they get it, if they can't figure out their age after 3 tries, we just either choose an age for them or just go somewhere else, or leave them alone and let them just cope with whatever they're dealing with. So like we would say, okay, we would have to have a counter. So we'd have a counter, and every time through the loop, we would increment the counter. I'm going to have to adjust this. I'm going to have to say loop while age is less than 0, or counter is less than 4, let's say. So we're going to ask them for their age. We're going to increment a counter, so it'll start at it'll ask them and then set the counter to 1. As long as that age is less than 0, loop while age is less than 0, this should be an AND. The age has to be less than 0, and the counter has to be less than 4. Both things have to be true in order to loop back. Because what eventually might happen is they might keep getting the age wrong, and the counter gets over 4. Right? Well, let's see what we get. So if I keep putting 0, oops. Well, age is less than 0.
Counter equals 4. Because right off the bat, you're already
Hmm. Yeah, you're right. Okay, so loop while age is less than 0. And right. So age will be less than 0. Counter will be less than 4, so it should loop back and ask again.
It's already less than
No,
4.
put that greater than in there. That should work.
Oh.
Or you be free.
Yeah, it
You
didn't.
just put equal to 0. You're putting in 0 and it's not less than 0.
Oh. Here you mean.
Yeah.
Yeah. Okay, let's try that. Yeah. 0, 0, 0. Yeah, that's better. Okay. Yes. Thanks. Okay, so, well, it still tells them that there's 0 when they bail, so what you probably want to do is say if counter is equal to 4. Call 911 immediately. Assistance. Else. Age. That seem all right? So if they're right, and or if they say, you know, I'm -3. No, I'm -2. I really am -1. Right? They need help. But if they figure out, oh, I'm not 0, I'm 30, then we let them through. So, you know, this would be, what were we doing here? Oh, yes, limiting a reprompting group. It's just sort of like only gives them a certain number of tries. So another use for this would be like a login, where they get, you know, a certain number of tries, and then you reformat their hard drive, or or the real fun one is when you've got 3,000 passwords and you log into a bank account that you haven't used in a long time, or it's really bad for a cell phone because they really get on you for that. And you can't remember your passwords, so you got 4 or 5 that you normally use, and you try 3 or 4 of them, and then they lock you out, and you got to call and send a urine sample in to get your account activated again. So stuff like that, right, where the website will lock you out. That's what we're talking about here. So loops are used for that kind of stuff too. I probably should save all these out on the Blackboard system for you. So I'll do that. I'm going to do that. I better save them. So let's see. Example 1. 2, 3. Validating a data type. This is something that FreeBasic doesn't really do very well. I was looking today for a function just to see if something's a number. It doesn't seem to be able to handle that. But in reality, like back in that Windows app we were doing, you know, we didn't do this there, but I still have it out. Actually, I still have it out there. We could bring it back up. Pull up Visual Studio, and one of the things we said was they're supposed to enter their mileage data, but they may put in, instead of numbers, they might put letters. Well, one of the things we can do when we test this is check to see if it's numeric or not. And so like right here, if starting, let's see here. And in this language, the way that you have to do this, let's see, I want to do this here. int32.try parse. I'll just fix it up and then I'll explain it. I'll have to get it working first. Starting miles. Starting miles. Let me see if it works first, and we'll. So I'm entering numbers. Oh. But if I enter letters, it says you must enter a number for starting miles. So in this language, it's got the capability to check to see if something's numeric or not. It would be nice if there was a function that said is numeric, but that wouldn't be painful enough. So instead what they do is they make a method called try-parse, and it tries to take the text and parse it into an int 32, which is a 32-bit integer. And if it can do it, it stores it in starting miles, and the function returns a true. If it can't do it, it returns a false, in which case I have an if statement that checks for that and puts up a message box telling them they must enter a value. In English, that means it checks to see if it's a number. So, this is something where this is very specific to this language, so it's, in every language typically is different on this kind of thing. But it does work. I mean, it can't get away with putting letters in there. So, see, I didn't use a loop for this. See, that's the thing. What they're talking about in the book here is, yeah, you'd want to have a loop, right? So if they didn't put the number in, you'd ask them again. Well, see, what I did in the Windows app is I don't ask them again. I just say fix it, and they have to click the button again. So that's one of those things, with a Windows Forms app, with the user interface, you don't use loops as much because it's event-driven. And the event, if they don't get it right, they have to redo the event, which is clicking the button. So, and I could write the same code on a web page, and it would be the same code, except it would come up in a browser. So it applies also to web pages that are based on controls like text boxes and things. So I should put this out online too. You won't be able to see this without Visual Studio, but if you want it, I can stick it out there too, just in case you have Visual Studio or you want to get it. Yeah, valid. Okay, that sounds like the same thing. So we're to our summary, and why should I say everything I just said? Okay. So, loops. Now, in your assignment for this coming week, next couple weeks actually, so I put this introduction out, which just tells you what planet we're on, what the schedule looks like, where we're at. Next week is our last week, and we meet on Thursday, so everything needs to be in by 11:59 p.m. Because when I say midnight, I get confused. So 11:59 p.m. on Friday night, which would be next Friday, right? Yeah.
We have 1 week to.
Oh, it's not next Friday; it's the following. Yeah, that's what I'm confused already.
Next week's our last class.
Yeah, next week's our last class. It's a lab night, so we'll be over in the other room, and then it'll be due. I should look at the schedule. It'll be due.
The way that reads, it makes it sound like it's due next Friday.
Yeah. Let me look at it again here. Today's the 1st. Next week's the 8th. Yes, that is saying it's due on next Friday. I'll probably push that out to the following Monday. It gives you the weekend to get it wrapped up. Why rush it,
This weekend's kind of shot, so.
Well, this week, yeah, it's a holiday, exactly. So you should be, but you won't be sitting around writing code all weekend. But you should be. Not really. Okay. So, yes, I'll push that from the 10th. I'll push that to Monday following. So that means then the last assignment is not due until following Monday. Not next week, but the following Monday, which is the, what is it, the 12th? 13th, right? 12th, okay.
13. Well, I don't know.
That's a Saturday.
Oh, nice.
Yeah, the 20th.
Yeah, the 20th. Nice. Okay. I'll massage the dates, you know. I was never very good at that date stuff. Okay. So, anyway, it won't be due next week. It'll be due the following Monday. So next week we'll meet in class. We'll have the lab time for it. And then we'll do the following Monday. So
So if we don't get it done Thursday during class next week, how do we get it to you after that?
you don't have to give me a printout. Just give me the zip files or zip file. That's good enough. In fact, the printouts are, if you give me the printout, I can mark it up and get it back to you. If you don't give me the printout, then I just have to type in what was wrong. But I do put the solutions out, and I haven't done that yet for 3. I just got done grading 3 today. And what I'll do is, so like if you look at weeks 3 and 4, for example, that was where we did assignment 2. The solution is out there. It's in a PDF file. And I did that for the first 2 assignments. I didn't do that yet for the 3rd one. But now that we're past the deadline, I could. The 4th one, which is due tonight, I'll have out there probably by the end of next week. Whatever the 5 days, whatever is passed for the late cutoff. And then the last chapter, what I'll do on that, I guess I'll have to email that to you. Because I can't, though you won't have Blackboard access probably a week or so after class ends. They usually cut it off pretty quickly. So I could just email it to you. It'll be a PDF file with the solution in it. So. Okay. Any questions on the schedule? So I'm going to turn off the recording.